fellow NASA Hunch students and teachers. My name is Miss Brittany Koger, and I'm going to be walking you through the final investigation for our magnet test. So this is investigation station number 3 and number 2. This is our magnet test station. So you should have already done the microgravity introduction, weight and measurement, and the other 2 magnet tests before getting to this one. This one is our final magnet test. All right, so let's think about what we know about magnets so far. So we know that a magnet has a north pole and a south pole, and that opposites attract. A north pole is always going to attract a south pole. South pole is always going to attract a north pole. They're going to stick together. Remember, attract means to pull together. Repel means to push away. All right. There's a magnetic field around this. So if I was trying to put 2 south poles together, you would feel that field. It would not let them go together. Same thing with the north pole. They won't go together. All right. So I got this bar magnet to be able to test my little refrigerator magnet. So I went and bought a pack of these at my Dollar Tree. Here in my town, you can go to Walmart and buy these. They're very, very cheap little round refrigerator magnets. You're going to need a metal pan to throw them in, or a metal tray. You can use a cookie sheet. You can use a magnetic tray. You could use a pot or a pan that's metal, or, this is just a little cake tin I got at the Dollar Tree as well. I used it because we want it to stick to it. But I used my bar magnet to see which side is which on this little magnet. And then I painted that with Sharpies, and I wrote on it north and south. So my students knew which side was the north pole, which side was the south pole. So I let them actually do this. I let them test to see which side was which. So we're going to see, see, there's a magnetic field there. This would be my south pole side. So I would paint that blue. And to prove that's my north pole side, it is red. All right, let's try that north pole against that north pole. Not letting me put it together, but that south pole and that north pole sticks together. All right, so now I have one side that is red and one side that is blue. So now I know my north and my south pole. Now what I am going to do here is I'm going to act like this magnet is a dice. I'm going to use my metal pan, and I'm going to throw this magnet into this metal pan multiple times. We're about 10 times a piece. So we're going to go underhanded first, like you would regular roll a dice, and then overhanded. I'm just going to drop it. We're going to see if that makes a difference on how this dice reacts. Okay, so let's look here and we will see. All right, I'm going to take this in my hand. I'm going to roll it around. Don't want to see it. Oh, look at it. It landed straight up on its side. I don't want that to happen, so that's a mulligan. I'm a golf person, so mulligan means a do-over. We're going to try again. We're going to try it again if it does that. Oh, okay. So now, looking at it, you have to remember that what side you see up, it is the opposite side sticking. So I see my blue side up. That means this north pole stuck. So for roll number 1, underhanded, I would put my north pole stuck, or you could just put an N for north. We're going to do it again. We're going to roll. Boom. Oh, that time my south pole stuck. So this time I would put my south pole down for roll number 2. And you're going to keep doing this about 10 times a piece. Ooh, south pole again. And you're going to, like I said, you're going to, north pole again. So right now, I'm pretty even at seeing that my north pole and my south pole stick to this metal pan about the same. All right. And then you're going to do the same thing. You're going to roll it around in your hand, and then you're going to drop it from overhanded. South pole stuck for my first one. All right. Oh, south pole again when I drop it. Maybe I'm just not flipping it around good. Oop, on the side of my pan. North pole stuck that time, so I got 2 south and 1 north. And then you're going to take all of your data and you're going to compare it with the other people in your group or at your table. Now, if you're doing this whole group, talk with it as your group goes. If you're doing this individually, talk about the people around you, or maybe do this whole class and talk about it with the whole group and see which one stuck the most, which one stuck the least. Have them go through and count how many times North Pole stuck and now South Pole stuck. All of that is in your slide and on your PDFs. If you need to print that out, that will be there as well. But we want you to roll. We want this dice to react as natural as possible up in space where there's 0 gravity. It's not going to act supernatural, because here on Earth we have gravity that pulls it down and makes it roll, but we're not going to have that. So we want it to stick, and we want it to be a different number every time, or we want it to just kind of be random for the number that it lands on every time. So knowing whether one pole is stronger than the other pole is going to help us decide whether to make the bottom of our game board metal or whether to make the bottom a magnet and throw a metal ball at it, or a piece of metal in a dice at it and let that stick. We're going to see. We're going to see which one sticks more, but we needed to know North Pole or South Pole, which one sticks more, or is it pretty even, or, is it close or similar? So that's what we're looking for in this one. The biggest thing, of course, is to have fun and record your data, because we're going to use all this information in our later investigation stations as we get into our dice rolling, our dice probability, and then for our dice game design at the very end. You're going to take back all of this information, all of these tests. We're going to take all of this recorded data, and we're going to use that to design our game board in the very end. And we want to design our game board the best that we can to help our astronauts with their mental health in outer space. So I hope you guys had fun with this project. Take as much time as you can on each one of these stations. And go back. If you want to roll it more than 10 times, roll that dice 20 times, 100 times. Roll it as many times as you can to see whether that North Pole is going to stick more than that South Pole. Go off into as many science lessons as you can. Gravity, force and motion, magnets, weight and measurements, all of that's involved here. So make sure that you're going over those with your students and covering those science standards as well. All right. I hope you guys had fun with these stations. Our next stations are going to be some dice investigations. So we're going to see how dice naturally react in our next couple of stations. I hope you guys had fun. See you later, guys.